Polar coordinates are another way to locate points in a two-dimensional space. Instead of giving an x and y ordered pair, you can give an ordered pair that gives the distance or the magnitude of the distance from the origin to the point and the direction theta. Theta is measured from standard position, so counterclockwise from the positive x-axis. That is polar coordinates. Example 1. Express each vector in polar coordinates in the form magnitude and direction. So vector A, the magnitude of A is 6. The direction is 45 degrees. Vector B, magnitude is 4. The direction, it's in standard position. So it'll be 270 minus 72, which is 198. So 4 is the magnitude and 198 degrees. Scalar components for a 2D vector. Let's consider a 2D vector with the tail at the origin and parallel through its tip to the coordinates axes intersect the x-axis at Vx and y-axis at Vy. So there's components or magnitudes Vx. And this magnitude is the magnitude of V times the cosine of theta, because theta is here, and Vy is magnitude of V times the sine of theta. Okay, cos and sine, you physics folks will know that really well. It's the x and y component. Okay, example 2. Express each vector in scalar coordinates, or that means xy pairs, and in the form where the vector v is equal to vx, vy. So, vector A has an x component of -2 and a y component of +3. Vector B has an x component of +2 and a y component of -1. To convert a vector from the polar coordinates to the scalar components, you just use this relationship, which I put on that diagram. Good. And to get the magnitude, this is Pythagorean. And to get theta, well, tan theta is Vy over Vx. But check quadrant. You must check the quadrant when you're doing that, right? Right. Okay. Do the required conversions. Okay, to scalar components. So AX will be 10 cos 120. AY will be 10 sine 120. So those are special. This will be -5. This will be 5 root 3. So the vector A is -5 and 5 root 3. B, convert to polar coordinates. Magnitude of B is the square root of b sub x squared plus b sub y squared. So it is equal to -4 squared plus -7 squared. Root of 65. Tan theta is by in this case, by over bx over bx. So -7 or -4. So theta is 60.26 degrees. But we're in third quadrant, so 180 plus 60.26. So vector B is root of 65, 240.26 degrees. That's it.